All right. Oh, good. Now this works. Um, okay. Sorry I didn't have audio. Thanks, Vishant. Just fixed it. Oh man, that sucks. Um, okay. Well, I'm pretty sure it should be working now. So, if you're watching this and the audio isn't working, leave a comment, um, in the chat, please, so I could get to it if it's not working. Okay. So, back to this. So let's go. We have our file name, optimization data slash file slash fancy date slash uh, fancy date and then double underscore file index dot csv. Um, for file. Okay, let's actually make it a folder. So let's say for folder in os.lister optimization data, if folder is equal to fancy date, then if folder is equal to fancy date, then we're going to say um, for file in os dot lister of f of optimization data, oops, optimization data slash folder. Okay, so now for file in here, if file dot split of split it on a period, get the -1. If that is equal to, oh, make it lowercase. Now if that is equal to CSV, then we're going to want to increment number from this date. And then file index is that. Now fancy date, instead of that, just slash file index.csv. Um, okay, now for file, if folder is equal to fancy date, um, now has date folder is equal to 0, which is the same thing as false. Has date folder. If folder is equal to fancy date, then do this, and we're also going to say has date folder is equal to true. And then after that whole loop, we're going to say if has date folder is equal. So if we don't have the date folder yet, let's go ahead and make it. So let's make optimization data slash fancy date. Okay. Um, analysis equals analysis 1 trend 3. Okay. Now we have our optimizable function. And then we're going to say with open file name. So with open file name a plus file underscore name as f dot write. So we want to write x int profit. Define optimizable func of parameters. So let's just do the same thing here, but we're going to write our column names. All right, now let's try to run it. Optimization data, fancy date, bounds, and then we get res is equal to differential evolution. All right, so now let's do add a Boolean in here. Test optimization is equal to 1. Now if test, so if we want to test the optimization, if test optimization is equal to true, then we're going to say optimize line location of seasons. np.arange 2007 through 2017 dot to list. All right, and let's see how it does. Write takes exactly one. Oh. Um. Ugh. So we don't want to write this. We want to write that. Okay. Oh yes. Okay. F dot write. So we want to write a function string that has these. Then let's just delete the directory if it got saved at all. Okay, and run it one more time. F dot, damn it. F dot write. Add the ending there. Index error, tuple index out of range. What does that mean? So it comes when I called. Oh. Okay, so do it again. Now optimize line location of these years. Then it takes us to here. It says the problem is in res equals differential evolution, optimizable func bounds, pop size equals 10. Then we get a problem in differential evolution. Self.parameter count equals np.size. So, oh, optimizable func. No, it gets params of 0. Um, will that do it? Something to do with something to do with the tuple. Whenever I have problems, it's always with the bounds and stuff. Let's see if this is where it is. No, same problem. All right, let's just look this up. Print birds of 5. Birds, 1, 2, 3, 4. So print birds of 5, then the code returns. Now this is happening with differential evolution. Do we know anything about that? That's because the bound parameter expects a sequence of min-max pairs. Given that you only have a pair of min-max values for x, you can do the following. Okay. So h comma, I don't know what the, does it need to be a list? A list of tuples? Maybe. Let's see if that does it for us. Right. Don't want that. We want xint. Get rid of this, and then xint is what we want to pass in. Okay. I don't know if now this is the error that I'm used to getting. Let's see. Bounds is equal to that. Yep, same problem. All right. So something's still wrong with how we're defining our bounds. Optimizable func bounds. Okay, I gotta go to the bathroom again. Be right back. Okay, so we're trying to figure out what's up with our bounds and why that's causing it to fail. Man, this is just the most frustrating thing to deal with. Um, I only have one parameter. Hmm. All right, let's put the debugger in here and see if we ever even get to this line. Okay, so we do get there. Let's see what the params look like. Okay, now let's see. Does it go all the way down here? Or does it not make it down to that line? No, it doesn't make it there. Now, does that work? Nope. So we get the x int, but as soon as we have to do anything, it fails. So let's try to do this. Copy that. Aha. What does that mean? The requested array has an inhomogeneous shape after 2 dimensions. What does that mean? Now we're into new territory. I've never run into this before. Keep being afraid I'm gonna get a chat and never reply to it. Okay, so assess x int. X int. It's because we're trying to pass in an array, I think. So what if we pass in x int of 0? Profit is 0. What's x int? 540. Okay, so let's go back in here. So now we'll see, does it make it to the bottom? Oops. Okay, now our question is, does it make it down there? No. We're still dealing with this error. I don't, I guess I don't understand what the problem is. Let's just, no, come on, man. What is going on? Hmm. Index error, tuple index out of range. Now, what is giving us that error? I'm just stumped. Let's make, I've never done it with just one parameter before, so let's make a fake param. The bounds for the fake param will be 1 to 2. Okay, so at least that worked. Now, why do we need a fake? Okay. So it works with the fake variable added in to optimize. Okay. I don't think that's gonna work. I think that fails. But let's go try it. All right, run analysis 1. Damn it. Might be because that's there. Hell yeah. Thank God. All right, cool. Now we have today, and there's a million optimizations because a bunch of them didn't work. Okay, and what did we optimize to? Oh, damn it. Forgot to add a new line every time. All right, let's just delete this whole thing. Now, every line we write, we want to start a new line, including that first line we wrote. All right, save it. Now let's run it. And see how it looks. Or we could just plot it. Um, let's actually just add a plot to the optimization. So plot is bool, and we're gonna say that it defaults to, let's default it to false. Um, Now if plot is equal to true, we're going to do two plots. I always forget how to do subplots. All right, so let's get an example. That's what we want. All right, so fig. All right, cool. Now, so if plot equals true, we can do that. Now we're gonna do ax1 dot plot. Oh man, we want to plot it on axis 1, but that's not going to work. All right, and then axis to plot on is equal to none. Okay, axis to plot on, oh, and the type should be, I don't know what type an axis is. Um, all right, matplotlib.axes. Oh man, import matplotlib. Okay, now the type should be matplotlib dot axes dot underscore subplots dot subplots dot axes subplot is equal to none. Is that not a... What's not valid about that? All right, let's just put this before the typed argument. Um, seasons, axis to plot on. What is the error? Statements must be separated by new lines or semicolons. Oh man, that's dumb. Axis to plot on is equal to none. Now, okay, if axis to plot on is equal to none, plotter is equal to PLT. Else, plotter is equal to axis to plot on. Okay, so now instead of here, we say plotter. Every time now it says PLT in this function, we want to change that to say plotter instead. So, okay, so now plotter equals that. No, plotter dot scatter, plotter dot scatter, plotter dot plot, plotter dot xlim, plotter dot ylim, and then plotter dot legend, and then if title is not equal to none, then plotter dot title, plotter dot title, and then if axis to plot on is equal to none, then go ahead and show the plot. Now we can take off the optimization test and turn on the plotting test just to make sure that that code all works. Okay, very good. So now we can pass in a subplot and get that plot on there. So fig if plot is equal to true, then we're going to get subplots. Then we're going to do analysis dot plot region. Okay, so now data is equal to pd dot read csv of file name. So now let's read the CSV. Now let's go see what that CSV looks like. Python 3, import pandas as pd, pd.read csv of optimization data slash pd.readcsv optimization data slash 2023-12-12 slash 0.csv. Okay, then a equals that, a dot x int. Cool. A dot profit a dot profit data frame attribute has no profit. A dot keys profits. Okay. Okay, so that'll fix that. Now data is equal to that. Now ax1 dot plot data dot x int and then data dot, do you have data dot x int and then data dot profit. Label ax1 dot x label is eval number and then ax1 dot y label. Oh. Guess we want to do scatter. Fig ax1, ax2, ax1 dot x label. So we want to see how the profit. Yeah, let's just scatter it. So x int ax1 dot y label is profit, and then ax1 dot title is optimization results. And then best x int is equal to, let's go back here, let's say a of space profit dot min dot max. Cool. A of profit dot max. So best x int is equal to a dot profit dot max. And that's not a here, it's, what do we call it? Analysis. All right, and then we could say analysis dot plot region. Plot region, and then we're gonna say x int is equal to best x int. We're going to say seasons is equal to seasons, and we're going to say axis to plot on is equal to ax2. Then could we pass in a title? So now let's do title is equal to bets, and then we could do plt.subtitle, and the super title is just whatever the, all right, so super subtitle is, make it a function string, and then we could do date time dot now, subtitle f of date time dot now, all right, gets the, may as well do the pretty date or fancy date, whatever I called it. All right, so fancy date dot replace, and we want to replace every underscore with just a normal space. plt.subtitle, that should be fine. Then let's show the plot. Plot by default is equal to false. Now let's do optimize line location. Plot is equal to true. And then plt.save fig. So we want to save it as file name, but okay. So file name dot, oops, file underscore name dot replace, and we want to replace CSV with PNG. And then we could show it. So let's exit out of here and try that optimization again. Fancy date dot replace, invalid syntax. Oh. So these should be single quotation marks because I'm using double on the outside. All right, now let's see if that runs. Cool. Oh, we're running the wrong thing though. So we want to test the optimization and see what that plot looks like. So it's optimizing now. The plot should pop up soon. Oh, damn it. Forgot the subplot stuff. So, man, okay. So this, okay, so we have to change the plotting. Now, I wonder if we could just change it to be set X label and set Y label. plt.plotter.x label x1.x label. Oh, it's down here. x1, okay, so set. So now we have to use set X label, set Y label, and set title. Okay, yeah, let's just run it again. Now we're gonna have to also do that to some extent in the plot region code. I'm gonna grab a coffee real quick. Okay, so analysis 1, trend 3, object has no object attribute profit. Analysis dot profit. Oh, so it's not analysis, it's data dot profit dot max. And then the plot region isn't going to work. Let's just try this. I'm gonna see if set label works on plot. So from matplotlib import pyplot as plt, then we'll do plt.plot. From numpy import a range as a. So we're gonna say plt.plot a 0 to 10, and the other thing we're plotting will be the same exact thing. And then plt.set x label. Does this work? Right. Okay. So if access to plot on is equal to none, plotter.scatter, then we plot it. Do we not set labels? All right, so if access to plot on is equal to none, then do this. Otherwise, do go ahead and do that. And then these need to be set underscore. So if we've passed in a access to plot on, then we set it. Then plotter dot x label is away team change in odds close to game time. And then the y label should be the same thing. Except it's the home team change in odds. Okay, now finally, if we've passed in an access to plot on, we want to do the same thing but set the labels. Okay, now let's see if that works. Wins, losses, win odds, get analysis, line 98 in plot region. Plot analysis. Analysis.plot region. '98 in plot region. Right. Get analysis. So self.training data. So we also want to pass in data. Oh, oops. We also want to pass in here data. And then get analysis should be data. Now, data defaults to none. So it will default get the training plot if data is equal to none, data is equal to training data equals self.training data. All right, so where are we at? So we're close to being done. So if if we haven't passed any data in, then use the training data. Now let's go down here. Um, optimize line location. Um, so the problem is, oh yeah, I hadn't defined training data. Analysis dot separate data. So let's just add that in before we plot. All right, analysis dot separate data. Training seasons is seasons. And this one's 2016, we'll say. It doesn't matter what training data is, or test data is. All we care about is the training data. And training data is the first one in there, right? Yep. Okay. Now this should work. Let's run it. I'm gonna run to the bathroom real quick. Okay, we're almost done. We need to call set title now though. If title is not equal to none, then we're gonna do so. If title is not equal to none, if um, axis to plot on is equal to none, then just do this. Now, if we pass in an axis to plot on, then we're going to want to do set title. Okay, now let's run it and see how it does. Nice, hell yeah. So we see that obviously there was a, man, we want to do tight layout. Okay, so let's add that and then let's make a nicer title of the whole thing. What should we make the title? Um, so let's say optimize line location. The title we're going to make plt.subtitle. Fancy date, replace the underscores. Um, optimizing for seasons. I think that should be fine. Um, then we want to do season plus put the single quotes around there and then oops, single quotes, and we could do season plus \n for season in seasons. Uh, That actually won't look good. Season for seasons and season. Season for season and seasons. All right, now let's go back to here. Okay, so I think what these values are we're making more money as we're going up here, but then as soon as we run into this, we start losing money. Like, what would those values be around? Oh, no, those are around 0. So we started, the peak was here. Trying to get how this data is laid out. Man, it's all over the place. But where's 0 profit? Oh, so we're almost always making profit. When we lose money, even these are slightly positive, I think. Yeah, 0. Minus 750, minus 500. Huh. It's almost like you could say just take the bets below the line for the home team. It seems like the dominant trend here is this line. It's like if we could get all bets below this line and ignore those two groups. Ignore that group. So we could do some, that shouldn't be hard. That should be pretty easy to do some learning thing on here to identify these groups and then say if it's in one of the forbidden groups, stay away. Okay, so I'm happy with this. Now the question is, what is our next step? Let's let's just remake that plot while we think. So, let's check how the stream's doing. Man, I did good at one point. I got 4 concurrent viewers, but then they all tuned out. Um, huh, that sucks. And then I periodically get 1 viewer. Man, that was my chance when all those people popped in. Um, okay, so back to this. Let's get this and throw it in our PowerPoint. Okay. So the optimization works. Now, testing optimization for each year 2000. So we're going to write what we want the test to look like. So for each year 2000 to 2021, training data is equal to all previous years. And the test data is just equal to the year. Um, Optimize on training data. Okay, so test data equals year. So then we want to optimize on our training data, record profit on test data. So where's our profit function? Right, assess x int. Now this we're going to call perform optimizations. Don't need to pass any arguments. And we could use what I just wrote in the PowerPoint to build it up. So back to the chat because I'm so afraid of missing something. Now shrink this a little bit. All right, so for each year, 2008 to 2021. All right. All right, so perform optimization. So for all years, we can call all years is equal to np.arange, a range from 2007 to 2022, and then turn it into a list. Now for year in all years, training data is equal to np.arange 2007 to year. The first year we want is 2008. Training data is 2007 to year, and then you get two lists. Now, what's that look like if I say np.arange from 2007 to 2008? Okay, so we will get 2007. So training data equals that, then test data is just a list containing the year in question. Okay, so we've got training data and test data. Now let's say optimize on training data. Optimize line location. Okay, so let's start an analysis and let's separate the data. Okay, so for year and all years, now we have analysis is equal to analysis 1 trend 3. Analysis is equal to analysis 1 trend 3. Then we're going to do analysis dot separate data. And we're going to say training seasons is equal to this shouldn't be data, it should just be seasons. All right, seasons. All right, training seasons equals training seasons, test seasons is equal to test seasons. All right, so now we've separated the data. Oh, actually we don't even need to separate the data. We can just say optimize line location of seasons. So now we're going to say optimize line location of seasons. And then we're going to say, okay, let's take this out, put it in here. Okay, then we're going to say, take that out too. Put that up there. And then we're going to want to return the best x-intercept. So then we get x-intercept is equal to optimize line location of training seasons. Okay, so this is all years since 2008, 2007 not used because why are we not using 2007? No previous data. Okay, now for year and all years, perform analysis for each year. Uh, Training seasons is all seasons prior to the current. Season to test is this year, is the current one. Initialize analysis, optimize on training data. Okay, and then analysis dot assess intercept. You just pass that in and then give the seasons. Um, so and now result is equal to analysis dot assess x-intercept, and we're going to pass in our x-intercept, and then our seasons is test seasons. Get profit for a current season from model. And then we're going to say results is equal to an empty list. And then we're going to say results dot append result. And then from matplotlib import pyplot as plt. Plt.plot results against test against, so plot all years and results. Let's just scatter it, and the size should be we should actually just save this. Okay, so let's make a data frame. Year, all years, and then So year, and then in that we want to give the list of all years, and then the next key will be profit, and the key will be results, and then df.to CSV analysis 1 trend 3 wait, what? Not to clipboard, to CSV. Analysis 1 trend 3 results dot CSV. Trend 3 results. Let's go make that a directory. Make dir analysis 1 trend 3. All right, then we'll put that in analysis 1 trend 3 slash test all, and then results.csv. All right. Now get perform optimization. Perform optimization analysis is equal to 1. Now if perform optimization analysis is equal to true, we're going to want to go do the optimization. So if perform optimization analysis is equal to true, perform optimizations. Okay. And let's run that and see how it does. This will take a while. So let's go update our Trello board. Assuming that this works, I don't know why it wouldn't. Let's just look at this really quick. Probably we want to save some metadata for the optimization. So let's go write that in really quick. For folder, so it gets each folder if so it gets each file name. So let's make another thing called the metadata file is equal to file name dot split. I want to split it on the dot and get the 0th element, and then you just add to it. Metadata dot text, and then with open metadata file a plus, and what's the metadata we want to write? With that as f dot write seasons and that's the only real thing to find that we're optimizing for. So yeah, this is still running. So that'll save the metadata. Now let's go see how many of these have run. Okay, so this was probably the first one. No, probably this one. Okay, let's say this is the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Should be close to done. Nice. Okay. Now let's go look at those results. Um, from pandas, import, read CSV as R. Now we could do A is equal to R. And what we want to read is analysis 1, trend 3 slash test all results dot CSV. Oh, so it didn't actually do that great. Okay, so we have matplotlib, port pipelines. Okay, so let's do plt.plot, a dot year, and then a dot profit. A dot year, a dot profit. And then show it. Hmm, interesting. All right, so we have the analysis we were trying to do. It doesn't always reliably return a profit. So we're going to have to look at, is there a way to adjust this analysis so that we do get a profit? Um, Hi Barcote, is it Barcote or Barcote? Hi Barcote, Barcote Nicholas. Hello to Kenya. I'm in the United States. Greetings. Hello Kenya. Why are you here, Barcote or Barcote or Nicholas? Whatever you go by. Put in the chat what you go by. Yeah, why are you here? Are you interested in coding or are you interested in making money from sports betting? Or both? Um, because I'm trying to do both. So let's go back to our Trello board. All right, now we finished that analysis. Go here so I still see new chat stuff. All right, and let's write some notes. Analysis completed, does not reliably make money. Okay. Um, and then I guess we could try updating every game or something. Attempt analysis on analysis 1, trend 3 with um, higher data rate, with higher update rate. Barcote. Nice, you're interested in both. Me too. Well, you're in the right place then. Um, because that's what I'm doing. I love coding and I like to bet on sports, but every time I bet on sports, I lose money. So, um, that's not high priority. Let's make that medium. Um, I like betting on sports, but I always lose money, so I'm trying not to lose money while still betting on sports. And what do we all want? We all want money so that we could be comfortable and live nice lives. Um, so now what do we want to do? We have that analysis. The question now is what to do with it. So let's actually do the same thing, but we want to get the plot for each one. So if plot is equal to true, um, let's just make another one for show plot. Now this one should default to false because we don't want to be showing the plot every time. And plot should default to true because we do want to save the plot. Uh, Now if show plot is equal to true, then we show it. Okay, now that will save every plot no matter what. And I want to look at the plots so that I could put them in the PowerPoint. So let's just add a title here. Or we could add titles and labels. Uh, Analysis, results. Um, Optimizing on previous seasons, test on current season. And then this we could just say is results colon optimizing. Okay, and then let's make the x-axis year, and then y-axis is profit in dollars on $10 bets. So if you're constantly making $10 bets, if you take every bet this strategy says to take, and each bet you place is $10, then this is what you end up with. All right. I guess the results should vary from year to year. Um, so now here's a question. Does the optimization give different results every time we run it? Um, so now, did we put that in? Yep. So let's snip something else. Get the data. Okay. And that's all we need for now. So let's exit out of here and run it again. Make sure that it's saved. Show plot defaults to false, but plot defaults to true. And we perform optimizations. Okay. Now we're going to redo that. And then Let's copy this, put it in here, and then after this current one finishes, then we could test them against each other. Oops. And see if it does change each time. So this is first run, gives us that stuff. Now copy. This one will be second run. Any tips being a better developer? Currently I'm into data engineering. Yeah, the number one tip I have is just do it. Um, yeah, you just get out there and do it. Lots of times when people are trying to learn coding, they try to like go through a class or whatever and kind of rote use rote learning like brute force to learn stuff, and that doesn't really work. A big thing is motivation because if you want to be a coder or a data analyst, it's a years long project. So um, you have to be ready to say, okay, in 5 years I'm not going to be done. In 10 years I'm not going to be done. And so the only way to really stay motivated is if you have interesting stuff to do during that in between time. Um, and the way to have interesting stuff is you just get projects. So if you want to be a coder, just think of something you want to do. It could be anything, and go try to do it. And if you fail at it, that's fine. Um, it doesn't matter if you fail because you learn stuff every time you fail. Data engineering's cool. This is a lot of data stuff. Data's fun, but in the future they're going to use ChatGPT and everything to do all that stuff. So you probably don't want to rely on data, or you don't want to be a data guy. You want to put all your eggs in the basket that nobody else can do. Find something other people can't do. Okay. Now I hope that this finishes soon. Oh yeah, let's see what years are we training on. Yeah, so we're getting up there in years. It should finish soon. Let's go back to updating our Trello board. So, don't want to miss any more chats. Um, okay, so that's still a question about we want to figure out the nan values, but that isn't so pressing right now because it seems like we have something that works. Okay, so let's take the high priority off. Um, so we've finished this first analysis. Now, um, we want to brainstorm ways to tweak analysis so that it is consistently profitable. And once we have that, we want to execute it. Um, bottlenecked. Why is this bottlenecked? Okay, so that's not bottlenecked. It's just low priority. Um, also low priority. From the stream yesterday, there was that guy talking about developing an ELO model. So now let's see if I can develop an ELO model. And that's also low priority. Um, so yeah, we've basically finished this analysis. We just have to wait for this to complete. Um, and it has completed. So now let's look at how does this change. So minus 16 for the first. Yeah, it looks like it's getting the same exact results, which is good because we're optimizing to the same point. Um, let's just make sure that that's the case. Okay, so for the second run, minus 16, 22. Oh, so there are some slight differences. The differences seem to happen more in the recent years. That kind of makes sense though, because there's more data that they're training on. Um, let's see. So it looks like it's the same. So minus 16 is the same, 22 is the same, 5.29 is the same. Then 2011, we end up with different results. So it was obviously using a different region. So we're going to want to find the region that it settles on. So the optimization gives different results when we run it. They tend to be generally the same though. Um, okay, so that's going to be added to our to-dos. Get optimization to consistently give the same results. And this is high priority. Why does the optimization return different results when it performs the same run? See PowerPoint. Okay, so that's our main thing there is get the optimization to consistently give the same results. And also high priority is brainstorm ways to tweak analysis so that it is consistently profitable. Okay. Last thing, well, I guess that's pretty much it. We could just plot the same thing. Oops. I guess we also want it to be in terms of percent return and not profit. Okay. And then change output to be in terms of percent return instead of profit on constant $10 bets. And that's high priority because that's going to help us look at stuff. Okay, and then we have to reconcile the differences and see if we can tweak it to get something that works. Okay, nice. Well, that's it for today's live stream. When we started the live stream, we had a way for making the bounding box. So the start of this live stream, we had a way to make this plot right here on the right. And we got in green are bets we took and won, in red are bets we took and lost. In this live stream, I've written code that figures out, okay, so for that bet, how much would you win or how much would you lose, and then return the total percent, or sorry, return the total money that you would have won or lost if you'd make constant $10 bets um, on each bet that you take here. So we got something then that returned the profit. If you're taking every bet in this region, what's your profit? And then we optimized that profit for a range of seasons and then tested it on the subsequent season. And the results of that test are here is the numeric results and here's the plotting results. Every optimization doesn't get the same region to do. So we end up with different curves for different optimizations. So on my next stream, I'm going to focus on making this more consistent so that it gets the same curve for every optimization. I'm going to put things in terms of percent return instead of profit. And then I'm going to attempt to tweak this model so that we end up with a better model that makes money every season. So that's yeah, so that's pretty much it. Thanks for watching, um, and I'll look forward to doing the next stream.